All right, welcome back to Ox Tools. I'm Tom. So today what we're working on, we're going to work on these, or one actually, thermal isolators for this Pratt Whitney level. When I got the level, excuse me, it had one broken thermal isolator. The bottom was completely corroded, and I rescraped it, and then Robin Renzetti offered to rescrape it in the Moore tradition, which he did, and it's just absolutely beautiful now. So it's really time to finish this thing up and quit milking this job, and as they say, and make a thermal isolator. It's a simple part. Now, there is some kind of learning opportunities here, because what we're working with is phenolic sheet. And it's a laminated material, but it's also kind of frangible too. It wants to kind of break, so you got to be a little bit careful when you're milling it, in particular in the directions that you kind of attack the material. So we'll do a little demo, and then we'll go ahead and make the part and get it fitted up and finish this little monkey off. So let's get cracking. All right, so here's a piece of our phenolic sheet, and it's just been rough bandsawed, okay? And you can see even with the bandsaw that there's some chipping of the surface material here. So this is pretty common in ceramics and certain kinds of plastics that are real hard. Phenolic does this, wood does this. So anyway, there's some techniques that you can use that help minimize that that breakout, so to speak. Okay, so what we've got here is we've got a I don't know, it's a 5 flute, I guess, 1, 2, 3, or 6 flute, I don't know. A lot of flutes. So this reduces the chip load per tooth, right, so that there's less pressure. That would be a reason to use a tool like this. These are great for profiling. They're not so good for ramping in and things like that. So typically you're going around the outside edge of something or a single wall where you have good chip clearance. Okay, so let's do a test cut, kind of what I would call the bad way. Okay, and you can kind of see the problem. And so we're just gonna come down on top of that and just touch off. Okay, and then we're just gonna go down a little bit. All right, so this first one, this is how not to do it, okay? And I'll just explain. The cutter rotation's this way. So what's happening is we're cutting, and we're coming out into unsupported material, right? So it tends to blow that wall away, right? So ideally we would be cutting on this side where we're cutting into solid material. But let's see what happens here. Actually, you know what? Let's do this. And you guys can see it live the first time here, okay? Oop. Hey, put it in gear, Mr. Wizard. Well, that's not too bad. All right, let's do the other side. I think I can do worse than that. There we go. I can hear it. I can hear that edge breaking out there. Okay, so that's what I'm talking about. You see what's happened here is that material is just chipped out, okay? That side was actually pretty good. I was kind of surprised there. All right. Blow that off. All right, so let's do this. Let's do it, quote unquote, the correct way. Maybe it's the depth of cut. Let me try a little deeper depth of cut, where there's a little more pressure on it. Yeah. Okay. You see that? Yeah. Maybe this particular piece is better on that side. I don't know. let's take a look at it here. Okay, so there's a good one there. It just blew the corner off of it. All right. And, you know, it's a little chippy along there. This side, for some reason, seems to be doing okay. So, all right, so let's go back and do it again. So this is how we'd like to see it. And then I'm going to stop when I get close to the corner. I'm going to come out, come into the corner, same thing that way. Out of the corner. Like that. So you saw I approach those corners a little differently there, and then we get nice. I think that was left over from our other one, so we're not going to count that. But okay, so that's one thing you can do with these kinds of materials. This is how you approach the direction of cut. All right, so we're going to drill some holes now. I'm going to drill the holes before I carve out this material underneath. And the reason is that way I don't have to support it. It's going to be a blind hole. So for the same reasons we end mill into the material, we're drilling into solid material so it doesn't blow out the back. Okay, so we don't have an exit wound, so to speak. So when we mill this off, we'll get a nice clean edge to the hole. So let's go ahead and do that. Let's see, am I in the right spot? Yep. Okay. We're just going to go in partially here. And I've also put some marks on here because now the part's going to have an orientation that I need to keep track of. So that would be the reason for marking it now. There's an asymmetry in these holes that I don't want to pull a bozo move on. Oop, hey. Hole's not deep enough. Oh yeah. Pretty good. All right, time to cut some chamfers now. We got little chamfers that we want to cut on this. And I'm using a 45 degree or 90 degree countersink to cut 45 degree chamfers. So let's, actually, so I'm referencing the back jaw. That way I can just rotate the part around. And this jaw is fixed in relation to the cutter, so I can cut the same chamfer on a bunch of different edges. Looks pretty good. Okay, I think we got it. Just to give you an idea of how sensitive this instrument is, I'm just going to push over here with my finger. Just a little bit. I got maybe, I don't know, a pound, 2 pounds, something like that. So let's see if this is enough to do it here. It's settled here. So this is an exquisitely sensitive instrument and should be treated as such. So this will go in its box, and I think we have a happy Pratt Whitney level. And special thanks to Robin Renzetti for helping out on this, and Andy Buchanan for finding me a piece of black phenolic, the old black phenolic. So thanks for watching, guys. I hope you like that. Okay, so I know there's probably a bunch of guys out there that are having a conniption about using hot glue on the surface plate, but as you can see, if you need to attach something down, a fence or a stop or something like that, this is a really good way to do it, and you can see that it's on there pretty good. Now this is the secret sauce for releasing it. I'm just going to give it a little dribble of that, and ta-da! And this just pops right off. See that? So denatured alcohol, for some reason, really makes this stuff want to release. And so anyway, I'll go over this and make sure there's no residue on it. But that's the secret.